Okay, here we go with page 2. DF bisects angle EDG, find FG. Okay, so this is actually unit 6, lesson 2. If DF bisects angle EDG, that means those two angles are congruent. But that also means that point F is equidistant to the sides, so these two are the same. So we can find N now pretty easily. So N minus 5 equals 7. I just subtracted N from both sides. N equals 12, but it says find FG. So FG is 2 times 12 minus 5, so 24 minus 5. FG equals 19. Number 20. How are angle 1 and angle 2 related? This is unit 2, lesson 5. This is where we first were introduced to vertical angles. These are vertical angles. Therefore, they are congruent, since all vertical angles are congruent. Okay, number 21. Explain why the triangles are similar, then find the value of x. So this is unit 5, lesson 3. Explaining why the triangles are similar, you have 3 options there. You have angle-angle similarity, side-angle-side similarity, and side-side-side similarity. This one is definitely not side-side-side because we would need all the sides labeled. Okay, so it's definitely not side-angle-side either because I've only got one side of the triangles that I know for both. Okay, so this is 5, the whole thing is 15. Okay. This is 9, we don't know what this is, so I can't use side, angle, side. How am I going to do angle, angle? Well, I have parallel lines here. What that means is these are corresponding angles, so they're equal. And these are corresponding angles, so they're also equal. So we have angle, angle similarity. Now to find the value of x, I need to set up a proportion. 5 over, but I need the whole side here. It's going to be 15. Why do I need the whole side? Because 9 is a whole side of the triangle, and x is the whole side of a triangle. We can't use side splitter here because the side being split is over here. These sides are not split. I got 5x equals 135, and x equals 27. 22, solve the proportion. This is actually algebra 1, but we'll say unit 5, lesson 1. So we're introduced to proportions. So 5 times 2x plus 3 equals 6x. So 10x plus 15 equals 6x. So 15 equals negative 4x divided by negative 4. Get x equals negative 15 over 4. Or negative 3.75. If t is the midpoint of SU, find the values of x and ST. Alright, so this is unit 1, lesson 5, where we dealt with midpoint. Actually, no. Segment addition postulate is what this one is, which was unit 1, lesson 3, I think. So, a while ago. So, if t is the midpoint, that means ST and t are equal. You can find x pretty easily. X equals 18. Then it says find ST. So, ST is just 4 times 18, which is 72. Number 24, in triangle ACE, G is the centroid and BE equals 15. Find BG and GE. So this is unit 6, lesson 4. So if it's the centroid, that means the distance from the vertex to the centroid is double the distance from the centroid to the midpoint. So G is the centroid, we know that. BE is 15, so the whole thing is 15. This piece is double this piece. So 2x plus x 3x equals 15, x equals 5. So that means GE is 10, and BG is 5. Okay. Number 25 is Unit 6, Lesson 5, Triangle Inequality stuff. List the sides in order from shortest to longest. Okay, so the shortest side is across from the smallest angle. The smallest angle is 48, so the shortest side would be KL. The next shortest side is going to be across from the next shortest angle, so this is 65. So JL would be next, meaning the longest side would be JK. Okay. 26, if angle B is congruent to angle C and angle C is congruent to angle D, then using the transitive property, what conclusion can you make? This is Unit 2, Lesson 4, where we dealt with the properties. Transitive property just says if this is equal to this and this is equal to this, then the first one's equal to the last one. So angle B is congruent to angle D. 27, LO bisects angle NLM. LM equals 15, NL is 6, OM is 8, and find LN. This is Unit 5, Lesson 6. So I'm going to label all those pieces. LO bisects NLM. So these two angles are congruent. LM equals 15. NO equals 6. OM equals 8. Find LN. This uses the angle bisector theorem in setting up your proportion, which just says x over 6 equals 15 over 8. So 8x equals 90. X equals 90 divided by 8, which is 11.25. Given that CB is the perpendicular bisector of AD, so CB is the perpendicular bisector of AD. CB is perpendicular to AD. It bisects AD, so these are equal. Can you prove triangle ABC is congruent to triangle DBC using the HL theorem? Technically, you could. But the best way, the quickest way to prove these two triangles congruent would be saying that CB is congruent to itself, and then by the reflexive property. But then the triangles are congruent because of side angle side, not HL. You could technically get to HL theorem, it just wouldn't be the most direct way. So this one was Unit 4, Lesson 5, which was HL theorem. Okay. 29, find the length or values of x and y. This one's dealing with angle pairs, which is Unit 2, Lesson 5. Okay. I see that we have vertical angles which are equal, so I can find x that way. 3x plus 1 equals 154. I also see that I have 13y and 154 make a straight line, so it's a linear pair. So they add up to 180. So there's my two equations, and I'm just going to solve both. So 3x equals 153, x equals 51. 13y plus 154, subtract 54. 154, you get 26, and y equals 2. There you go, 51 and 2. Sarah wanted to measure the height of her school's flagpole. She placed a mirror on the ground 52 feet away from the flagpole, then walked backwards until she was able to see the top of the pole in the mirror. Her eyes were 5.5 feet above the ground, and she was 15 feet from the mirror. Using similar triangles, find the height of the flagpole to the nearest tenth of a foot. So here's your flagpole. Okay? She placed a mirror on the ground, and that mirror was 52 feet from the flagpole. She then backed away until she was able to see the top of the flag in the mirror. Okay, so these are right angles. These angles are equal. The angle of inflection is equal to the angle of reflection. Okay, so she was 15 feet from the mirror, but she's 5.5 feet off the ground. So 5.5 feet is how tall she is. Okay? So those two triangles are similar because of angle-angle similarity. And now I can set up a proportion to figure out how tall the flagpole is. So 5.5 over 15 equals how tall the flagpole is, x, over 52. So 15x equals 52 times 5.5, so 286, divided by 15, I get 19, to the nearest tenth of a foot, so 19.1 feet tall. Okay, that was actually very end of Unit 5, Lesson 3. I did that, talked about that in that lesson. Okay, 31, name two segments skew to TU in the diagram. So skew segments was Unit 1, Lesson 2. So two segments skew to TU. So TU is here. So skew would be VZ or SW or WX or ZY. The thing that those all have in common is that they're never going to touch TU, but they're also not parallel to TU. That's what skew is. Okay, number 32, given all that stuff, find the perimeter of triangle DEF. So this is Unit 6, Lesson 1, which was mid-segments. CB is 40, so the whole thing here is 40. EF is 14. AE is 17. So if AE is 17, then EB is 17. The whole thing here is 34. Okay, AD, if this is 14, this is the mid-segment that's parallel to AC. So you double that to get, this is 28. Okay, but we're trying to find the perimeter of DEF, so we need DE and DF. DF is half of 34, it's parallel to 34, so that would be 17. And DE is parallel to CB, it's half of 40, so that would be 20. So the perimeter would be, those added up, so it's 31, 51 would be the perimeter. Another way of doing it, we could have added up those. So 34 plus 28 plus 40, got 102, divided that by 2 because the perimeters are, the perimeter of the mid-segment triangle is half of the perimeter of the whole triangle. So, two ways of getting that. I don't care which way you go. Write the inverse of this conditional statement. Inverses were Unit 2, Lesson 3. Inverse just negates both the beginning and the end, or the hypothesis and the conclusion. So, if two lines intersect at right angles, so do not intersect, at right angles, then the lines are not perpendicular. And that's the inverse. You just negated the meaning of both the hypothesis and conclusion. There was no flipping or moving anything. It was just negating or giving the opposite meaning. Write the contrapositive of this conditional statement. So contrapositive is 2, 3 as well. If an angle is acute, then it measures between 0 and 90. Basically what a contrapositive does is it takes the inverse and then switches it. So if an angle is not acute, then its measure is not between 0 and 90. All right, so I'm going to take that part though and write it first. So if an angle's measure is not between 0 and 90, then it is not acute. Okay, that's the contrapositive. 35. So triangle has side lengths of 4, 4, and 7. Classify the triangle according to its sides. This was Unit 3, Lesson 3. Or no, Unit 3, Lesson 4. We talked about triangles, classifying them. So we're classifying them by sides. 2 of them are the same. This is isosceles. Basically a vocab question. 36. Given the statement, an obtuse angle is an angle with a measure between 90 and 100. Write this statement as conditional and write the converse. If both are true, write the definition as a biconditional. So I'm going to use shorthand here because this one could take a little while, but this one is Unit 2, Lesson 2. It's also Unit 2, Lesson 3 with the biconditional piece. So the conditional would be if an angle is obtuse, then its measure is between 90 and 180. The converse would be just switching the order of that. So if an angle measures between 90 and 180, then it is obtuse. Okay, so now we have to find the truth value of both of those. If an angle is obtuse, then its measure is between 90 and 180. That's true. If an angle is between 90 and 180, then it is obtuse. That's also true. Since they're both true, we can do a biconditional, which just says an angle is obtuse if and only if, that's the biconditional part, its measure is between 90 and 180. Okay. A lot of writing there, but hopefully you got the idea. 37, find the length of the altitude drawn to the hypotenuse. Express your answer in simplest radical form. This is Unit 5, Lesson 4, the one everybody dreaded. It's also 5.5. That one was the shortcuts. I'm going to use the shortcut here, which says the altitude is the geometric mean of the two hypotenuse segments. So this one's set up actually pretty nicely. You get x squared equals 84. Now I'm going to break down 84 into 4 and 21, 7 and 3. So it's a pair of 2, so this is 2 radical 21 is what x is. 38, the rectangles are similar. Find the value of y. I'm telling you they're similar. You don't have to prove that. I know 5 matches up with 12. Therefore, 8 matches up with y plus 3. So this is Unit 5, Lesson 2. So 5y plus 3 equals 96. So 5y plus 15 equals 96. 5y equals 81. And 81 divided by 5 is 16.2. Last one is side splitter. So that was Unit 5, Lesson 6, which, because these are all parallel, I can say 6 over this equals this over this. So 6 over whatever this is. Well, the whole thing's 11, so this would be 5. So 6 over 5 equals 2x plus 4 over x plus 6. Cross multiply. 6x plus 6 equals 5 times 2x plus 4. 10x plus 20, 36 equals 4x plus 20, subtract 20, I get 16 equals 4x and x equals 4. Okay. You could put that in to check it to make sure. That's going to be 12, that's going to be 10, 12 over 10 does reduce to 6 over 5. So 4 is my answer for that. Next video we'll do the last page.